Winglets are used today to increase an aircraft's aerodynamic abilities while flying. When an aircraft is in motion, tip vortices form at the ends of its wings. This is from the rotational motion of the air flowing off the wing, causing drag on the aircraft. Winglets reduce drag on an aircraft by forming smaller, more disoriented tip vortices. The winglet being fabricated is for a wing piece used in the experimental research in classes at the University of Wisconsin-Madison's wind tunnel. We brainstormed many ideas and narrowed them down to 3 designs. The first design involves cutting a hole in the winglet and inserting screws into the winglet. The holes in the winglet start large enough to fit a screw in them, but they continue to get smaller as you rotate the winglet. You will screw bolts into the wing piece and the winglet will have holes to insert the screw. As you twist the winglet, the screws will be locked into place.
The second design involves attaching a screw shaped with a Phillips head or a key to the wing, also cutting a hole in the winglet that matches the shape of the screw that was attached to the wing piece. The screw is then inserted into the winglet and twisted to lock it into place. The last design involves attaching a metal plate to the side of the wing piece using screws, also constructing a winglet with the magnets embedded inside of it. Then the winglet is attached to the side of the winglet using the force of attraction from the magnets. We built many prototypes using different materials like regular foam, EPS foam, and wood. After evaluating these designs and materials using a design matrix, we chose our final design. Our preliminary design included 2 pieces, the attachment piece and the wingtip piece. The attachment piece and wingtip piece were glued together. Then we drilled a hole horizontally through the winglet and used screws to secure the winglet to the wing piece.
To fabricate the winglet, first the design was marked on basswood to indicate where to cut. Then the wood was cut into blocks using a bandsaw, and the rough shape of the winglet and attachment piece was created. The attachment piece and the wingtip piece were shaped to the correct shape using an orbital sander and belt sander. Then we drilled holes into the winglet using a drill press for screws to go through. We then installed threaded wood inserts into the wing using a power drill. The wingtip piece and attachment piece were attached using wood glue and Bondo adhesive. Finally, we applied a smooth finishing coat of Gorilla Glue waterproof sealant on the winglet to complete the fabrication process. We tested our winglet to ensure that it met our client's standards and specifications. For our first test, we wanted to test whether the screws would be able to securely hold the winglet to the airfoil, and did this by screwing the winglet to the airfoil and leaving it there to see if it would hold, or would it fall off. For our second test, we placed the wing piece with the winglet in the wind tunnel to test durability. We did not add smoke and lasers yet. For our final testing, we placed the wing piece and the winglet with the wind, smoke, and lasers on and observed the vortex form. The vortex was smaller and more disoriented than the vortex with no winglet. After our 3 tests, we concluded that our project met the requirements of our client.